This is the annual super fun, happy OpenTSDB talk. How many people have been here for my previous TSB talks here? Really? Ooh, new victims. Cool. Okay. Anyways, my name's Chris Larsen. I'm an engineer at Yahoo now. And I kind of took over the project. It was created by Benoit, who's over here actually. So if you want to ask him questions or blame him for anything, you can talk to him. But anything that's happened in the past couple of years, you can blame me. That's okay. I've been kind of managing the project, committing a lot of code. We've been working on it at Yahoo a ton. And I also want to emphasize what I'm not a marketer or a salesperson. We don't have a company behind OpenTSDB. Some people might like one, I don't know. So I'm going to be honest, I'm not going to try to sugarcoat everything. But real quick, for anybody who hasn't been here before, OpenTSDB, it's a time series database. How many folks have worked with time series here? Time series workloads. Cool. So most of this should be familiar for you. OpenTSDB was created, kind of spawned out of Google and some of the ideas they had by Benoit here. And it was designed to store tons and tons and tons of data and keep it around as long as you wanted to, and scale up to millions of writes per second, which is actually in production, on top of HBase, or now, and we'll talk about it, on top of Google's big table. So time series are simply just series of discrete data or data points. They're all identified by the same common characteristics. So you might have some metric that might say, I'm tracking the web server CPU utilization on my host Web01, and you just track that value over time, right? And you can do cool things with it. You can graph it. You can feed it into machine learning algorithms. You can print it out in JSON, and you can read through it to help you go to sleep at night. What's a data point? It's going to be a single discrete measurement of that value at some discrete point in time. And then if you look at this, we have sys.cpu user. We have a timestamp, a value, 42, the great number. Then you have, in our case, tags, which are other identifiers that say, okay, this data point came from host Web01, and it was for core or CPU ID 0. All right. Most people here should be familiar with HBase by now. What is it and what's Bigtable? Distributed LSM backend for storing large amounts of data. It's a key value row-based kind of column-ish store. It supports scans, so it's just a giant distributed hash table, and you can scan over the data because it's ordered on keys. You can start at key A, and you can scan all the way down to key Z. And you can scoop up all that data in one request and send it back to whatever application you're reading it from. And if you follow the CAP theory for consistency, atomicity, I think, and partition tolerance, HBase is always focused on the consistency, sorry, not capacity, consistency and partition tolerance. A is for availability, sorry. I'm all disjointed here. So the one bad thing about HBase is that if a region server is down, you're going to lose access to your regions for a little small period of time. But you gain consistency from that, which is nice. You don't have to worry about reading something at one point and reading it later and getting a different value, assuming nobody has written to it. So OpenTSDB utilizes the HBase schema in the following way. We write row keys where we prepend a unique identifier that's assigned to a metric name. Then we store, and actually there's a little salt byte in that as of OpenTSDB 2.2, I believe we released it. Then we have the timestamp, which is normalized to an hour boundary. Then we have the combination of tags that make up the identification. And within that row, then we'll go and store individual columns for the data points. So we might have 1 hour in each of our rows of data. And if you write your data point every 1 minute, you're going to have 60 columns in there. If you write it every second, you're going to have 3,600 columns. If you write it every millisecond, you're going to really hammer HBase, but you could try it, and you'll have a lot of columns in there. We store exactly what you give us. So if you give us a floating point value, we'll store in either single or double precision. If you give us an integer, a signed integer, we'll store it up to 8 bytes, but using variable length encoding, if you give us a value of 0, integer 0, we'll just store 1 byte of data in there and save you a lot of space. So TSDB's format, encoding format, has been proven to be fairly, compressing and small. Another way to look at it this way, you've got your metrics, tag, timestamps, and then the tag values, and then you can have a whole bunch of different column qualifiers here. The column qualifiers start with an offset from the base time. So normally if you're writing 1 second data, it's only 2 bytes per column qualifier. Then you have the value is the actual value. In an OpenTSDB schema, we only really care about one version of the data. So most times when you're installing TSDB, you set versioning to 1. You don't really care about storing a lot of different values in the same column. So if you look on the right here, I've got a JSON query where I'm saying, give me metric 1, and then for tags, tag K1 and tag V1. So what it's going to do on the HBase side is set up a scanner with a regex filter. And in 2.2 and later, we also have fuzzy filtering and some other stuff I'll talk about in a bit. And it's going to start scanning the table in order over the regions and picking out the rows that match, and then return that to the TSD for processing. All right, so just some quick use cases. I know we have Lars from Salesforce. He nicely mentioned OpenTSDB. They use it at Salesforce for the back end of storing time series data for their monitoring system Argus, which is an open source monitoring system. You can check it out, get it up and running. I believe it's with Kafka. It has a built-in GUI. It's pretty cool, and they've been using OpenTSDB for a long time, writing lots of data to it. And same thing, since I come from Yahoo, I got to talk about us. We use OpenTSDB for our monitoring backend system too. It monitors everything at Yahoo, and soon to be Oath probably. Don't ask me about the name, didn't have any choice in picking that. But we write about, on average, consistently, we run about 10 million data points per second to our HBase cluster. We actually have 2 of them, so that's per cluster. And then when we're backfilling or doing something after maintenance, we'll peak up to about 16 to 18 million per second. If you were here earlier and you heard Francis and Fariful talk about HBase, we're just one of the tenants there, and we're their favorite tenant, I know. We never cause them any pain or any problems. We're such good people. So on average, we share the tenant with them. It's Kerberos secured, but not encrypted because monitoring data isn't super sensitive. And we have over 3 petabytes in there and tons of data. And we've been working on OpenTSDB publicly too. There are, of course, a bunch of other users in the community. Pinterest is a big user. They're working with us right now on some neat new features. You can check out all these guys. So let's get to the update part. I'll talk about 2.4, which I was able to, at the very last minute, squeeze out a release candidate last night. So if you're a TSDB user, go ahead and start playing with it, but do it in staging or dev, please. Don't do prod yet. I know there are bugs, or going to be bugs, so I need your help to find them, please. But the new features that we have here are something, first up is the rollup and pre-aggregations, which is something that we use heavily at Yahoo. Because if you take a look at a very high cardinality data set, let's say you're tracking clicks to a website and you're getting all these IP addresses from the public. Well, with IPv4, you had, what, 4 billion possible public addresses. Now IPv6, you have billions and billions and billions of those. And if you try tracking all of those, you're going to have, and you put that in a tag, you're going to have insane cardinality, right? You're going to have a whole bunch of unique values. And let's say you're getting a lot of traffic and you want to aggregate that or something for a query. Now, when you do that, that's going to fetch a ton of data from HBase, from storage. Did I cut out? No, I'm back. Sorry. And if you look at a wide time range, you're probably going to either out of memory or JVM of HBase or the TSD. So we implemented the rollup policy, which is common amongst time series databases and systems, and that you simply summarize your data to a lower resolution. For instance, you might take your 1 second data and summarize it to 1 hour. And now you can look at a year of data pretty easily at 1 hour resolution. And if you're graphing, you definitely don't need that 1 second data, because you're just going to see a solid bar of a blue or whatever color you pick, right? So if you want to actually look at some of that detailed data, then you want the summarized data first. Then if you want more information, you can drill down into a smaller view. So TSDB 2.4 supports storing and querying this data, but it does not allow you to create it. It doesn't do it automatically like some databases do, InfluxDB, for example. The reason of that for that is because calculating and generating that roll of data is something you generally at scale want to do separately. You don't want it within your same JVM of HBase or TSDB, because you're going to out, you're going to kill your write throughput, all those reasons. So at Yahoo, we do have all of that in a streaming layer built on top of Storm that we're hoping to open source as soon as we possibly can. And then we write that data to TSDB. Second feature that's really cool that I'll talk about is histogram data sketches and digests that you can now store in OpenTSDB for more accurate percentiles. Another thing we added was date tiered compaction support from the Salesforce team. Actually helped us out with that, in that it allows you to, I think I have a slide on it, I'll talk about it in a second, and also authentication. So we started off with authentication, and you can do that. So one problem, let's say you're using a common metrics framework like Drop Wizard or the metrics library, and it outputs these cool things called percentiles, where if you're tracking latency, right, you can look at your P99th, P50 for a median, that kind of stuff, right? How many people have used that kind of feature before, right? So now what if you want to aggregate that data across lots of hosts? Can you do it? Really? Not really. I mean, you can, and you're going to get a fuzzy result, but it's not going to be accurate. So if you take a look at this example, if you average your P99th, you're going to miss the outlier, right, of 58.98, whatever I picked there. You could use a max if you're looking for the worst case behavior, and that kind of works. But if you want the actual average or something, it doesn't work. So that's where histograms come into play. And I always think of histograms for some reason with, I'm thinking of Adobe Photoshop, because you can pick all the colors or gamma and that kind of stuff, and I'll show you a bar chart. You see it on nice high-end cameras and that kind of stuff. But histograms are also great for tracking latency. So what happens is that in its simplest form, you create various buckets of measurements. Let's say you want latency from 0 to 15 milliseconds, and you create a bucket. And every time a query comes through that took that amount of time, somewhere in between, let's say 13 milliseconds, you increment a counter inside that bucket. And then you add another bucket just to its right or adjacent to it, from 15 milliseconds to 30 milliseconds, et cetera, and you just keep incrementing counters. Now, the nice thing about these is that you can actually aggregate these histograms at a low level and get much closer to the actual percentile that you want. So in this case, if you average all of the percentiles, like the P99, that are generated from the histogram, and then try to average them, you're going to miss the real view of what you want, which is at the bottom of this row, 52, 52, and then 37. So histograms are great because you can aggregate them. And while they're approximate, you have a value error, meaning that you don't know exactly what the P99th percentile was. It's going to be somewhere in that bucket between 45 and 60 in this case. It may actually be 58.6 milliseconds, but in this case, it's just taking the middle of them. It gives you a much better indication of along a distribution as far as the, it's called the, I forgot the term, it's somewhere in here, the rank error, that's it. So histograms, the good thing about the TSDB implementation, they're fairly small and consistent. For 97 buckets per data point, it was about 877 bytes in my measurement there. And it can change a little bit. We use a cryo serialization, so it depends on the number of counts in each of your buckets. Again, it gives you better analysis. You can merge all these, downsample, group by, and we only support some right now, of course. Fixed rank error versus a variable value length error. The bad things, of course, are that if you're going to store these histograms, you're going to have to write all of these buckets and counters over the wire and then actually store them in HBase. So you have to be aware and be kind of picky about which measurements you're going to apply histograms to, because again, is going to eat up more storage. And also, we don't have any real libraries right now that we know if they'll encode this stuff very easily. I know there are some like HDR histograms and such that you can serialize and send over the wire. So that segues nicely in this one, in that the TSDB implementation is pluggable. So just off the past week, I banged together a couple of implementations. One of them is using Yahoo's data sketch, which is another way of approximating these percentiles by accumulating all of your latencies in a special data structure. And then you can, again, merge them, send them into TSDB for storage, and query them later on. So the data sketches, the benefit is that you get a little more precise value. It's not bucketed necessarily, but you have an error bounds on either side of the actual value. So the rank error is going to be a little different, but it's configurable. So you can pick your error, whatever you're comfortable with. So you have to balance off size versus error. The more data points you store in the sketch and maintain in memory, the smaller the error, vice versa. Yahoo's data sketches are open source, so you can go and poke at it. There are other cool sketches in there that you can play with that we don't support in TSDB yet. And another one that's kind of cool is the T-Digest. A lot of big companies are using this right now in their monitoring infrastructure. So it's another thing that's using trees as a data structure. It can store floating points. And it has very good accuracy at the extreme ends of the percentile range. So if you're looking at your P99.999s, go with a T-Digest. The bad thing is that it has less accuracy at the medians. So if you're looking at your P50, go with a data sketch or a histogram. So again, pick yours based on your use case. And all of these are available in the RC. They're plugins you can download from the OpenTSDB repo, and it's all configurable. And I actually got around to documenting it before the speech, so that should help people. All right, who here has an appendix? You know, sorry, I was just making a horrible pun here about HBase appends. So year or two ago, I was talking at HBaseCon about OpenTSDB. We implemented appends in HBase, wherein previously, if you write all 60 columns for 1 minute data in a row, you're going to have all those columns and you're going to have to read them out. And when you read them out, you're going to get the row key information, individual timestamps, or the version info from HBase. So if you can compact all of those in a row into one column, that saves you all the duplicated wire key, row keys over the wire, and the duplicated timestamps. So, hey, it saves you bandwidth, should answer queries faster, right? And it turns out that's true. OpenTSDB, when it was released, implemented something called TSDB compactions, which means that it ran a job after every hour was up that scanned every row that was written, read all of that data out, compacted it into a column, wrote that back to HBase, deleted all the old columns, and voila, you save space. Of course, in the process, you thrash your HBase servers because now every hour you're doing tons and tons of reads and a few writes and a lot of deletes, so that's no good. So what if we could just write all of that data into one column in one go? That's what the appends do, right? And that's awesome. So it saves you space. It saves you all of the network traffic of bringing that data back over the wire and then sending it back to the HBase server. And it worked pretty good. But the problems are that it does actually increase CPU utilization on the region server. And if the data has been flushed to disk and it's out of the mem store, then you have to read it off a disk back into memory whenever you're writing a data point and do a read, modify, write. Right? So our team at, oh yeah, so this is what I was talking about. Sorry, I haven't looked at my slides today. So you have longer wait times. Call time can go up in HBase, unfortunately. And the solution with our crack HBase team at Yahoo, who again love TSB so much, they're actually solving our problems for us, have started working on a solution that we're hoping to have public pretty soon. They won't let me talk too much about it, but it involves compact coprocessors. But it solves the read, modify, write dilemma, and we've been testing it so far. It looks really, really good. So we're hoping to be able to share that with you guys pretty soon. So this goes back to the date time, date tiered compaction framework. And that right now, HBase or OpenTSDB, of course, dealing with time series, is writing timestamp data all the time into HBase. As we do that, if you're updating newer H files and not updating old ones, the compaction code doesn't really have to necessarily worry about going back to older H files and trying to merge them, because they're not going to change. They're probably already ordered nicely with their indexes. So some folks, I think it started at Yahoo, started work on a date tiered compactor that looks actually at the timestamps of the columns in the H files and determines, hey, I haven't seen any updates. I don't need to recompact this guy. So I'm only going to compact the H files that I need to worry about. And they say that this has improved performance on their end. So we've got the folks at Salesforce who are testing this out for us. And they've added the support. Karen in PR 990, we got it merged into 2.4. So this is available for testing. I personally don't have any good data to share about this yet, but it's out there. All right, so I don't know how popular it is in the HBase community, but as an alternative to the native HTable client, there's been async HBase that came out of Stumble Upon and Benoit's work, which is a completely asynchronous HBase client using the raw protobuf API to talk to region servers, and also the ancient manual serialized byte structure of 92 through 94. So we just cut a release of that this weekend. It supports, I mean, it's a little faster than HTable on writes, but on reads, it can be slower depending on your workload. So you've got to look at that. But there are a bunch of companies like Pinterest and Flurry at Yahoo are still using async HBase. So the stuff that we got into this release were batched GET requests or multi-gets. That's thanks to the folks who are working at Pinterest. So now instead of doing an individual GET request, sending it to the server, waiting for the response, or asynchronously waiting, sending another one, you can batch all these together and send them in one go. We also have reverse scanning, which will help us for 2.0 when the get closest rows or whatever call disappears, sadly. That's going to be sad when it disappeared. We also add some support, we added a fix to be supportive with 1.3. So that's out now if you ran into scanning issues with that. Multiple column prefix filter, and then a couple of atomic increment patches went in too. And I mentioned Bigtable before. The folks at Pythian and Google wanted to be able to showcase some applications that would run on Bigtable when they decided to offer it as part of their cloud service platform. So they came to Pythian and us about OpenTSDB and saying, hey, Bigtable's backwards compatible with the HBase API. OpenTSDB should be able to run on it. Lo and behold, after the Pythian folks worked on it, bang, it worked. It was cool. So there are a few people using it in production. It still uses a shim called async Bigtable, which is taking our native TSB and async HBase API and just mapping it to the Bigtable or HBase API and then calling Bigtable. So in 3.0, we're going to have some work around cleaning that up to make it even more efficient. So speaking of OpenTSB 3.0, we've started on it finally. We've kind of been using a version of 3.0 at Yahoo internally for a small subset of our monitoring platform. And I've taken that, cleaned it up a bit, and started pushing it publicly. And then I'm about at the point where I can switch over to just using the open source version for production code. So some of the problems that people have complained about in the past that we're trying to fix with this, one of them, of course, being that queries are slow. And the order of operations are also immutable, meaning you can't do a rate calculation before downsampling, vice versa. So the way we are solving that is by creating a brand new query layer that's fully composable. You can say, I want to use this processor in this order. I want to query this TSB and this HBase table and take the results from this TSD and HBase table, merge them together, and then do the calculations and then serialize that. We needed that particularly at Yahoo because we run dual active-active HBase clusters. So we dual write everything, and then we query both clusters, merge the results, and return that. And that's how we achieve HA, and that's how we allow our crack HBase team to take a cluster down for maintenance and survive any outages. Secondly, we've started adding caching. Previously, we only cached PNGs in OpenTSDB. Now we're actually caching the time series data. We're also working with Pinterest on integrating Facebook's Berengi, which is an in-memory only data store for time series, which is kind of cool. And we'll have to see how that's going to perform. Another problem that we had is storing other data types like those histograms. If you look at the 2.4 code, I suggest you don't because it's ugly as heck, the way we squeeze histograms in there. So we're working on a pluggable storage interface now, which will allow you to choose HBase or Bigtable, let you choose various types of data that you store, because right now we just have the numbers and the page reload. And the histograms now. So we'll clean that up and be able to store more information in there. Also, we're working on anomaly detection. Yahoo released this library called EGADS that has a bunch of stochastic time series functions and analyses that we're integrating. We actually have this running in our in-house stuff, and I'm pushing up the code slowly to the open source group so that other folks can take advantage of it. And also, we're going to have some new Java APIs. So if you can take a look at what's there right now, which is the composable query layer, take a look at the APIs. Let me know if they're terrible, if I'm doing stupid stuff, and tell me how to fix it too. Don't just say, oh, this sucks. You know, that's not cool. We're going to support servlets. We've been netty-based so far, and that's led a lot of developers to complain. So we've added servlet support if you want to run it that way, if you like that JEEE thing. Which if you do, more power to you. We started tracing integration. Zipkin is really a nice tool to debug queries. And if you have any kind of query service, you ought to take a look at that for tracing your own applications and hopefully improve Docker support too. And since Benoit's created OpenTSDB, there's been an explosion of interest in time series workloads and tons of time series databases out there. So you don't, like I said, I'm not a marketer. I'm not going to say TSDB is the best thing out there. You can't use anything else. Don't do it. Check these other guys out, like InfluxDB. Almost everybody's heard of that. It's been a great database for replacing graphite on small instances. They do have scaling issues, though. Druid's another one, a columnar OLAP database that's heavily used for analytics at Yahoo. It's also pretty cool, but it can be expensive to run. And then stick around later. You'll also hear from Matthias about Warp 10, which is geo information time series data, which is pretty cool. So that's Warp 10 there. Gorilla, like I said, Prometheus is popular. That's a monitoring application. And then other guys in the SQL sphere are also getting into it. So take a look. There's tons of cool stuff out there. And just wanted to say thank you for Google for their support with Bigtable and hosting and letting me keep my Bigtable dev account up. Woohoo. It's expensive. I know I no longer have to pay for it. And also thanks for the HBase team at Yahoo. They've really gone through hell with us with OpenTSDB and pushing our write load. We've pushed them really hard. So thank them, and thanks Stack and everybody else for the conference. So any questions from me? That's it? All done? Okay. Thanks, y'all.